Hello everyone, welcome back. So today we shall have discussion on the architecture of a spacecraft. So overall a block diagram is shown here which will represent the spacecraft systems. All the working systems of a spacecraft which is in the spacecraft or which might be necessary for the working of a spacecraft is categorized into two parts. First one is called as a mission payload. Second subcategory is called as support systems. With respect to the mission payloads, there are several components or techniques or concepts that are collectively shown here, indicating that there is always a scope for future development. Under that, first one is a science. So this science is an intangible component of the mission payload, which will say that without science it is not possible to proceed with the mission payloads. So launching a spacecraft or placing the spacecraft in the orbit requires a certain set of method, certain technologies, certain pre-calculated trajectories, a strong control system, and many other things will be required. So the first important component in the mission payload is the intangible component which is called as science. The second component which is called as communications, which is shown here in the left side of the block diagram. Communication. It is necessary for each and every component of a spacecraft to communicate within themselves, and also it is necessary for the spacecraft to communicate with the Earth or the station which is present in the Earth. So this is where the machine learning is coming into the picture nowadays, and it has its own importance. The third component here is the mission payload. In the mission payload is surveillance. So it is necessary for remotely locating the faults in the spacecraft, within the spacecraft, and also mitigate that fault remotely. So that is where the surveillance, internal surveillance will come into picture. Also, we have to make sure that it is placed in the right orbit, and from there it is giving us the right survey. For example, if it is a geostationary or the global positioning satellite, in that case it has continuously take the survey of the Earth's navigative roads or flights or seaways. And for example, if it is a weather satellite, then continuously it has to survey the atmosphere. The third component in the mission payload is the weather. So this is necessary to establish the communication. If the weather is bad, we have to make sure that communication is not lost and it has to be very intact. Also, weather is considered as a mission payload, keeping in view of certain spacecrafts or satellites which are used for forecasting the weather. The fourth component in the mission payload is the navigation. So this navigation tells us where exactly we have to go. So there is a navigator device which will establish the link between the spacecraft and the Earth. The next component here is geodesy. So what is this geodesy? That we have So among the sensors, what we have to see, first one is the earth sensor. So earth sensor is a device for determination of the attitude of a satellite, maybe at an altitude of 500 kilometers or different levels. So this device also helps us to determine the position of the spacecraft with respect to the horizon or beyond the horizon. So the primary function of a earth sensor is to measure the altitude. The second type of sensor that is being used is star tracker. So star tracker is an optical device that measures the position of stars using photocells or camera. So this is very much necessary with the high degree of accuracy with respect to any spacecraft, may be used to determine the orientation of the spacecraft with respect to the stars. The third type of sensor that is used is accelerometer. So accelerometer is an electromechanical device used to measure acceleration forces. So maybe the continuous force of gravity, or maybe to sense this dynamic sense of moments or vibration, whether the device is still, stand still, or moving. So this is where accelerometer is used. In order to keep a spacecraft in the required position, it is necessary to get the output of the accelerometer very still. If the accelerometer is showing some disturbance in the output, then it majorly means that there are certain vibrations within or outside the spacecraft that is not allowing it to make it stand still. Fourth type of sensors that are being used are sun sensors. So it is a navigational instrument used by spacecraft to detect the position of the sun. So we all know that Earth revolves around the sun, and it is necessary for a spacecraft to know the position of the sun in order to know where exactly the Earth is located in the solar system. Next type of sensor that are used are gyros. So these gyro sensors are angular rate sensors, or also called as angular velocity sensors. So these sense the angular velocity, that is the orientation, whether it has rotated in any one of the x, y or z axis. So if at all we are placing a spacecraft in one particular orientation, and if there is no rotation, then the gyros should give us a stable output. But if at all in any one of the output of the gyro is showing the movements, it means that spacecraft is moving in that particular or rotating in that particular axis, and we have to recorrect the rotation. Next one is the magnetometer. These magnetometers are used to measure the magnetic field and also to sense the polarity, to know whether the spacecraft is at the north pole or northern hemisphere, or south pole, or at the southern hemisphere, and also whether it is near the equator or whether it is near the poles of the Earth. So these are the 6 set of sensors, not just 6, there might be many other advanced sensors nowadays. Collectively, the outputs of this sensor is going to a sensor interface. These are the decision making modules, which are electronic modules. Now sometimes sensor interface may give the command to a data to a control processor, and control processor gives the command via data transfer to the actuator drives, or sometimes the sensor interface will directly give the data, and the command handling center will take care of the high priority commands. So these are the different electronic modules, which are the processing modules. Output blocks or the actuator drives here. For example, let us say that while launching a spacecraft, we are slightly moving away from the required trajectory. Then the sensor interface will sense using the accelerometer and give the command to the actuator drive, and propulsion is corrected with respect to that. Now there are some sensors which are necessary for the setting of the solar panels in order to generate the electricity. If at all those solar panels are not oriented in the right direction, sun sensors will sense it and give command to the array drives, and that will orient the solar panels in the required format. And then we have this magnetic torquers, which will make sure that the spacecraft is in the right position with the help of the measured magnetic field. Then we have something called as a momentum wheels in order to prevent the wobbling or rotation of the spacecraft. Then we have something called as a gimbal drives, which is the output of this gyros, which will keep the spacecraft steady. And also we have something called as a control gyros, where each and every moment given by the gyro, opposing movement is created by this quantum gyros in order to come back to the original position. So these are the different components in the attitude control system that are present, and this is the overall architecture of the spacecraft. So that's all we have got for today. Thank you.